Okay, so in this problem they tell us locate each pair of points on a coordinate grid. Describe the direction from the first point to the second point. Use these descriptions to the left, to the right, downward, and upward. So in each of these sets, right, we have 2 points, and in each of them we're moving from one to the other. So in part A, we move from 3, 2 to negative 5, 2. So let's plot that. And then we'll also plot D, and then we'll talk about G. I'm not going to go over B, E, C, and F because I think we'll get the idea or the sense of this problem by looking at A and D. So notice that I want to use one graph here, so we should notice that the highest value I'm dealing with is a positive 20, and the lowest value I'm dealing with is a negative 5. So I think increments, we want to pick increments that will actually fit that range. So we go up by 1, 2, 3, 4, 5, 6, 7. We have 7 lines going up, and we have to reach 20, so we have to hit at least 3 per line. So let's use 3s. Not very common choice, but it'll work. 3, 6, 9, right? 12, 15, 18, 21. So now we can plot 3, 2. Let's keep this. Let's go up. Well, I guess we can distort this grid a little bit. We only need to go up to 4 on the x-axis, so we can go by 1s, 2, 3, 4, 1, 2. And now we're going down the y-axis. We have to keep that consistent, so we'll go down by 3s, negative 3, negative 6. So plot 3, 2. Remember, the first number refers to the x direction, and the second number refers to the y direction, so it's independent variable first. We go 1, 2, 3, and then to positive 2, which should, if this is 3, 2, right, this is 3 parts, 1, 2, about here. And that's the point 3, 2. And we're going from there to negative 5, positive 2. So go 1, 2, 3, 4, 5 in the negative direction, and then up to here. So negative 5, 2. Notice we basically just went to the left, right? From this first point to the second. I know I didn't go up or down, even though the drawing might look that way. Our height was the same in both points. You could tell it right away. In both cases, the height was 2. So that's not going to change. So for A, you could say this went to the left. And that makes sense because the y variable, the y coordinate or the y ordinate didn't change. It was 2 in both cases. Only the x coordinate changed from 3 to negative 5. In part D, we're going from 4, 4. So here's, I put a 5 here, I don't know why I did that. 4, 4 would be about here. That's 4, 4. To 4, 20. So still at 4, all the way up to 20. So this time, what happened? Well, this time the point only went up, straight up. Even though my graph might be a little bit off, we can tell that makes sense because in both cases, our x value never changed. We're not going anywhere to the left or right. Right? We're at 4 in both cases. Only the height changed and went from positive 4 up to positive 20. So each of these points, you can predict what's going to happen without graphing. So in part B, we can go. We're noticing, oh, it went from negative 7 to positive 3, but the y value didn't change. So what does that mean? Well, that means that only the x value is changing, and it's moving from the left at negative 7 to the right at positive 3. The height will remain unchanged. In this problem, the height is also unchanged. So in A, B, and C, the height never changes. In each case, we're going from the left to the right on the x-axis. And in D, our position left and right on the x-axis is not changing horizontally, only the height is changing from 4 to 20. In this case, in E, 18 is in both points, right? So the point's going to sit there at 18, somewhere over here. But it's going to go down from 8 to negative 8. So let's say this is 18, 8 up here. Well, 18, negative 8 is going to be down here. 18, negative 8. It's going to move in height. So again, only the height's changing in this point. And in 20, without graphing, we notice, again, only the height's changing from negative 4 up to positive 9. Negative 20 is remaining the same, so the height is changing in each of these. In E and F and D. Alright, hope that helps.